So good morning, everyone, and let's continue with the stack now. So we'll quickly go through whatever we have completed till now in a previous lab, and then we'll try to complete this entire program today. Okay. So in last week, previous lab, we started with stack implementation. So initially we had looked at init operation, push operation, and pop operation. And for that, we had defined our stack, normal structure, and we defined init, push, and pop functions in a single file, right? And that's how we started actually. Then we call a function and we found there is a problem because call by value will not work here. And we changed our program to call by reference. And then everything works perfectly. So we had last in first out structure and we tested it. After that, we thought of the separating implementation and a demo part, and for that reason we have created two separate files, stack.h file which will contain only implementation part, and main.c file which will have a demo part. This is just a demo, so anyone can have a look at it, how functions can be called, right? And what are the parameters. So we created two separate files. Then separation leads us to the abstraction part, and to make our stack fully abstract, we had also defined our user defined data type stack using typedef keyword. So using typedef keyword, we have created our own data type name, and then everyone can use this data type stack to declare a variable, right? So we had created abstract data type. And then to have a proper demo, we had also gone for menu driven program. So at last we had created menu, and based on the option we had we have created number of cases here, and from those cases we call a proper function. So that's what the status is, current status of our program. This is what we have completed till now. So we had looked at init function, push function, and pop function. Now peep, change, display, two more operations we can have is empty and is full, just to check whether stack is empty or full, right? So we can go for number of operations like this way. Sixth maybe is empty, seventh maybe is full, just to check whether stack is empty, whether stack is full, what. And the eighth option may be exit. So we need to create number of switch cases also, right? So option number 6, 7, and 8 will be the exit one. When you exit, if you do not write break, then it's okay, because program already terminates. Break statement is not needed. So let's complete this option number 3 to 7 today. Okay, and let us complete our entire stack. So we are talking about further operations on a stack today, and I'm going to first write those functions, and then I'll come back and write the demo code. So going to stack.h file, we have init, push, and pop. Next thing we want to create is peep, change, display, is empty, and is full. These are the functions we are going to create today. So let's start with the first one, peep. Now if you recall, and you can keep your algorithms side by side so you can compare those algorithms with this code also. Okay, So if you recall, pop and peep has a minor change, very minor change. Pop is going to delete the value. Peep is not going to delete a value. It will just return a value. So I can copy this code of pop and place it here. And let me rename this function to peep. Fine. So we want one value from the stack. If top is already -1, underflow message. Otherwise, we can take a topmost value and we can return it. But we are not deleting it, which means top minus minus will not be there. So I delete that line and I'm done with peep. That's the only change between pop and peep. Pop will return a value, it will delete a value also. So top minus minus. Peep will return the topmost value, but it will not delete it. So top minus minus nahi karenge hum. That's the peep function. Okay. Next thing we want to look is the display operation. Now, during this entire process, if you have any doubt, you can interrupt me and you can ask me the questions. Okay. Next is the change operation we want to look at. Now, change is just going to change the value. It will not return anything. So void data type. Change is the function name. Now, change, first thing we require is the stack variable. So stack pointer s. Second thing we require is the position, on which position user wants to make a change operation. And the third parameter we require is the new value to be so all value replaced by the new value, right? So we require value also. So there will be 3 parameters. Now again, if stack is empty, you can say that, oh, stack underflow message and so on, whatever you do. But instead of that, what we are going to do here is first, we need to calculate index based on position. A user has given a position and we need to calculate index because we are working with array, and array requires index value. Then there was one equation we had discussed in the lecture part. Anyone remembers? If you remember something, anything, please write in the chat box. What do you remember? Converting position to index. What was the equation there? Anyone knows? No one? So let's discuss and understand the structure first. So if top is minus, we can say underflow. Otherwise, we may go for changing a value. So when I want to change a value, how I can change it? So s points to data, and within that data array, on the calculated index position, I'm going to store a new value, right? And I can give the acknowledgement message. Value changed. That's the acknowledgement message, right? So I'm going to perform these 2 statements based on the if condition. So in this if condition, actually I need to validate this calculated index. Whatever idx value we have calculated, we are going to validate it. If it is valid, then we will make that change. Otherwise, in the else part, we can give a message to user that invalid position, because based on the given position we have calculated index. If that index is not valid, then in turn position is not valid. So we can give this invalid position message to user, right? So this is the structure. Now let's go back to IDX. Position starts from 1, 2, 3, 4 and so on, and it starts from the top position calculation, whereas index starts from 0, 0, 1, 2, 3, 4, and indexes are calculated from the bottom position, right? So to convert your position to the valid index, the equation was something like top minus pose plus 1. Anyone now recalls that equation? Top minus pose plus 1. And if you do have any doubt, ask me. We'll make it clear and then we will go on. So waiting for your reply. Clear? Are you clear with this equation? Okay. So this is how we convert given position to index, and then we need to validate that index here in the if condition. Your valid index will be in the range of 0 to top, because that's where your values are. So IDX should be or must be greater equals to 0, and it must be less than equals to top. Okay? This is the valid range of your index value. So if your IDX is in between these two, then it's a valid one. We will make the change. Else part will say invalid position. And that's the change operation. Fine. Now, next we are going to look at is the display operation. Again, display operation will simply display the entire content of stack. So return type is void. And then display is the function name. It only requires your stack variable to be printed. Fine. And here what we do is the first thing first, we check if stack is empty. We give a proper message. Otherwise, in the else part, we are going to print the content of entire stack. So we'll say stack contains, and in a new line, I'm going to print all the elements of stack. Okay, all the elements of stack. So I require for loop to print everything. We require for loop, and we are going to print the data %d, and we are going to print data. Data is the array, so it requires index. So from which index to which index we are going to print. Stack always starts from top, so your I will start from top. Okay, I is going to range from top to 0, so we need to make it I minus minus, and then the condition will be while I is greater equals to 0, you are going to run your loop. So this is your display function. Starting from top up to 0, we are going to print that ith value from the data array, and that gives me the entire stack. Fine. So this one is the display function. Then there are two more functions, is empty and is full. We have already done it. This is how we define emptiness. If top is -1, okay, then we say it is underflow, which means it is empty. So in isEmpty function, isEmpty function will have our stack variable, okay, and what are we going to do is we will check whether it is empty or what. Okay, if it is empty, then I'm going to return, actually we return true, but C program does not have Boolean data type. C++ does have it, but C does not have it. So true, we in a C program we cannot return true. Then what we do is we return a non-zero value, which is true, and if it is empty, then we return 0. So if it is empty, yes, it is empty, then true, non-zero value is true. If it is not empty, then return 0, which is false. So when we return 1 or 0, then the return type of this function should be integer. Okay, so integer will be the return type. Stack is empty, return 1, otherwise return 0. And similarly, you can do is full also. If it is full, you return 1, else return 0. But to check whether it is full or what, your top should be what? We had checked it in the push operation, overflow condition. What is it? If top is max -1. If your top is -1, then it is empty. If your top is max -1, then it is full. So this is full function. Is there any query? Is there any query? Okay, fine. So actually we are done with all the functions in the stack, right? So let me save this code, and now we want to test these functions. So let us go to demo file, where we have that menu already created. Just the remaining part is populating these cases, right? So pop and peep are almost same, so I can copy this thing and paste it. So here pop value is, instead of that we can say top value is, and then the value. So that's the case number 3. Then case number 4 is actually for change, right? But to call that change, we require 2 values. So let us have those 2 values. The first one we require, please enter a position, and we should store it in POS variable. And second is, please enter a new value, and we store it in val. So do we have these variables? Let us check it out. So we have val, we have ch, and we require POS also. Okay, just a variable declaration. Coming back to case number 4, we have position, we have a value. We can call a change operation where we pass our stack, then we pass our position, and then we pass a value, and done. It is not going to return anything, so nothing on the left side. Then case number 5 is the display operation. So let us call display %s. That's it. Case number 6 is is empty. So we call this function. Now if it returns true, means 1, so I'm going to call that function within if part. Then I'll print a message here. Yes, stack is empty. Okay. And in the else part, I'll say no, stack is not empty. Simple one. Yeah, based on the if condition, we print these two messages, and in the if condition we call is empty function. So similar structure we can use for is full also, and I call that full function, and here I'll say yes, stack is full, no, stack is not full. And that's it. I have completed all my function calls also. So let us save entire code and now run our code and test it, right? So I run my code and I have that stack initialized message, and then I have options. So initially my stack should be empty. So if I call option number 6 is empty function, then it will give me a proper message, yes, stack is empty. And if I call option number 7, then it should say no, stack is not full, right? Because it is empty right now. If I display, then it should tell me underflow message, right? So we have underflow message. Even if I peep or pop, it should give me underflow message. Again, option number 3, underflow, and option number 2, underflow, right? So those functions, initially those functions are working properly. Now let us push some value, enter 1, then value 2, value 3, value 4, and value 5. And till that time I have value inserted message. I have inserted total 5 values. Now if I go for the 6th value insertion operation, option 1, value 6, then it should tell me stack overflow. So when I insert value 6, it tells me stack overflow because my stack becomes full. It was a size of 5 elements, correct? And at this place, if I check is empty, then it should return no, stack is not empty. And option 7 should tell me yes, stack is full. Now if I check topmost value, so option number 3, peep, then that will be the 5. Okay, so it tells me top value is 5. Now let's display option number 5, and it is going to display the entire stack. Stack contains 5, 4, 3, 2, 1 in a reverse manner. So topmost value is 5. So display operation is also working properly. Let us check change operation also. So from topmost position, this is position 1, 2, 3, 4, and 5, right? So let's say on a 4th position, I want to change a value. So I will call change operation, option number 4. It asks me the position, so I'll say position number 4, and the new value. So instead of 2, I want to insert, let's say 8, and enter. And it tells me value changed. Let us verify, let us display option 5. So yes, instead of 2, we have 8 now. So index calculation is also being done properly. Now what if I give invalid index? Okay, let us pop few values first. So option number 2, 5 pop ho jayega, and again pop, and 4 will be popped. So now we have only 3 values, 3, 8, 1. Now let me call change operation. I have only 3 values and I'm going to give position 4 and anything, any value. But that 4th position is not a valid one. So when I go for it, it will also give me the message invalid position. Because based on this position, whatever index I calculate, that index, calculated index is not within the range of 0 to top. And that's why it tells me invalid position. So I have tested my code and let's say I'm satisfied with this one. Then now I will exit option number 8 and my program terminates, right? So that's what the practical number 3 is. Entire third practical we had gone for. We have seen few more options than this, whatever asked in your practical list, right? So this is your stack and we are done with the stack. Any query or question or doubt here? Okay, if not, then let's move on now. So look, initially I'm going to show you the entire code and then you are going to perform it. But eventually what I'll do is I'll reduce my content and धीरे धीरे मैं आपको खुद ब खुद पूरा कोड लिखने के लिए बोलूँगा, right? So because right now we are working with a new subject, new type of file structures, having 2 separate files and all. So because of that reason I'm showing you entire content. धीरे धीरे जैसे ही आगे जाएंगे queue and linked list, तब मैं क्या करूँगा, I'll show you the structure, I'll show you 1 or 2 functions and then I'll tell you, you complete all the rest. So you will have your practice also, fine? So let me stop here. I'm done for today's content. Now you are going to complete your entire stack. Whatever remaining functions are, you complete it, you complete your entire stack. And if you complete your entire stack within this lab, then also you can go for application of stack. That is the next practical we need to perform, and that is infix to postfix conversion program we need to do. Look, I'm going to show you that part in the next lab also, but some of you are brilliant and they are some of you are completing this code early, so you can move on and you can start writing your 4th practical if you have any idea. Otherwise, our today's task is to complete practical 3, entirely 3rd practical we want to complete today. So now I'm going to stop this recording and we all will be completing our code. Wherever you have any problem, you can ask me. We'll be here till 11:30, right? So do it now, complete your program.